On January 7th, David Bennett woke up just like he had every day before. However, this day was slightly different because he had a new heart. Mr. Bennett was waking up from the first successful surgery in which a pig heart was transplanted into a human. Now, most of us don't have to think about organ transplants that often, which is probably a good thing. However, transplants have become an integral part of medical science in the 21st century. According to the website for the United Network for Organ Sharing, last accessed October 8, 2022, almost 30,000 organ transplants have already taken place in the United States just this year. These procedures have given new opportunities to patients both young and old whose conditions were previously seen as being untreatable. Mr. Bennett's story is particularly noteworthy because his procedure was the culmination of decades of research on cross-species transplantation, otherwise known as xenotransplantation. Xenotransplantation is on the verge of revolutionizing medical science, so it's important that we understand this complex process by first looking at how humans began to use animal products medically, then looking at how years of research have resulted in modern xenotransplantation procedures, most of which involve porcine or pig organs. Finally, we'll look to the future and attempt to predict how all of this will be applied for years to come. Xenotransplantation isn't as new as many may guess. In fact, the first procedures involving animal components took place all the way back in 1667 in France, according to a 2017 article from the Smithsonian Magazine. The medical pioneer in question here was Jean-Baptiste Denis, the personal physician to King Louis XIV. Denis transplanted lamb blood into 4 young men, 2 of which died very shortly after their procedures. Their families accused Denis of murder, and such procedures were banned in France, as well as effectively becoming medical taboo for the next few centuries. Explorations into xenotransplantation picked up again in the mid-20th century when doctors began to realize that the reason for so many previous failures was the fact that the human immune system was rejecting the foreign organs. As explained in a February 2022 article from the Association of American Medical Colleges, doctors started to use immunosuppressive drugs when transplanting primate livers, kidneys, and hearts into humans. These patients had the chance of surviving anywhere from just 2 hours to as much as several months after their procedures. Then, as explained in a February 2022 statement from the NYU Langone Transplant Institution, porcine, or pig, organs started to replace primate organs in these experimental procedures. This is because porcine organs are more similar in size to human organs. Also, due to having more genetic differences from humans than primates do, pig organs are less likely to transfer harmful diseases during these experimental procedures, thus making their long-term success much more viable. Now that we've looked at xenotransplantation from its earliest applications, we're ready to dive into the modern work that's being done with porcine organs. Modern procedures involving porcine components have had increasingly tangible results that cause doctors to have an optimistic outlook on the future of xenotransplantation. A February 2016 article from the Journal of Tissue Engineering discusses the effectiveness of using porcine acellular lung matrix in healing damaged tissue in rats. Cellular matrices are mesh-like patches that surgeons use when they're finishing a procedure. The matrix acts as a helping hand for the afflicted area by supporting the growth of new cells, and the goal for the procedure using the porcine matrix in rats was to imitate how currently used cellular matrices speed up the healing process in humans. The main difference between currently used matrices and the experimental one is that standard ones are typically made out of human skin tissue, and the experimental one was made from a pig's lung membrane. At the end of the study, the researchers concluded that the porcine matrix had more cellular density and grew more blood vessels than the human one, both of which are very desirable traits for an acellular matrix. Another modern medical innovation involving porcine components is porcine fibrin sealant. Fibrin sealant is a liquid that is applied to wounds after injury, and it's meant to speed up the healing process. An article published in the Journal of Evidence-Based Complementary and Alternative Medicine in June 2022 describes an experiment in which porcine fibrin sealant was used to treat flesh wounds in rats and was shown to speed up the healing process more than traditional medical sealant did. The future of xenotransplantation became increasingly bright when doctors were successful in transplanting the first porcine heart into the aforementioned David Bennett in January 2022. NBC News published an article describing his story in July 2022. The procedure went smoothly, and Mr. Bennett was able to survive with the porcine heart for 2 more months before passing away. His cause of death is the biggest takeaway from this medical venture. He died because his body was ultimately too weak and the porcine heart failed. However, his body didn't reject the foreign heart. Since organ rejection wasn't related to his cause of death, the doctors considered the procedure a success, which means that porcine xenotransplantation is not only medically viable, but also that it has the potential to transform the medical field for years to come. We've looked at xenotransplantation from its earliest origins and what's being done with it today. So now let's look to the future and attempt to predict how all of this will come to fruition in the next few decades. Current xenotransplantation research can be seen as an investment in the humans of the future because it could be the key to solving a huge problem in the medical field, a shortage of donor organs, especially kidneys. According to organdonor.gov, last accessed September 25th, 2022, there were 90,483 patients on the waiting list for a kidney transplant in 2021. Of these individuals, only 27,760, or about 27%, actually received a transplant. Also in 2021, researchers at the University of Alabama at Birmingham were able to transplant pig kidneys into brain-dead humans, according to a January 2022 article from the Scientific American. The article describes how these pig kidneys were able to perform their vital functions, such as filtering blood and producing urine, for an extended period of time before the experiment was complete. Also, the researchers at the university are currently working on obtaining the necessary green light from the FDA in order to start conducting human clinical trials with the porcine kidneys. This implies that xenotransplantation could meet the demand for kidneys and other donor organs that will inevitably be greater in the future. Furthermore, many doctors are optimistic that the techniques currently being used in xenotransplantation can be applied to other areas. Currently, the animals being used in these experimental procedures are genetically modified in a way that reduces the risk of aversive effects from the procedures by making it harder for the recipient's body to recognize that the new organ is actually from a different species. This makes a rejection of the foreign organ much less likely, and after the positive results of David Bennett's procedure, lots of doctors hope that this can be applied in other areas of medical research, such as stem cell transplants. A July 2022 release from the Mayo Clinic describes how animal stem cells could be genetically modified and then transplanted into humans to aid in the regeneration of damaged tissue. This application of stem cell technology, plus the reduced chance of an organ rejection, and the possibility of having a larger source of donor organs from animals, means that xenotransplantation truly can transform the medical field as we know it. From early experimentations in animal blood transfusions to a man surviving with a porcine heart, xenotransplantation has undoubtedly progressed in leaps and bounds since its beginning. Today, we explored how humans first experimented in xenotransplantation with very few victories for multiple centuries, then how we developed our techniques in order to perform modern xenotransplantation procedures with porcine organs, before finally considering how these techniques can be applied to other areas of medicine, such as stem cell research. Thanks to patients like David Bennett, the use of porcine organs is becoming increasingly normalized in the medical field and will save countless lives in the years to come.